Hello everyone, welcome back to my channel once again. So after learning about the physical properties of metals and non-metals, we are going to start about chemical properties of metals. So let's begin. So while understanding the chemical properties of metals, so we have the first situation here. When metals are burned in air, what happens? So actually we are getting the oxides. They produce oxides when they are burned in the air. So here you can see on the screen a picture of magnesium ribbon is burning, right? And we are getting a white dazzling, white colored flame of magnesium oxide. So also you can see on the screen that is the equation for this reaction. 2 Mg here, 2 Mg which reacts with the one molecule of oxygen which is in the gaseous form, which gives rise to 2 molecule of magnesium oxide which is in the solid form. Similarly, when copper is heated, okay, similarly when copper is heated in air, it combines with oxygen, right? It combines with oxygen and to form, it forms the 2CuO, that is copper to oxide. Here you can see when two molecules of copper reacts with the one molecule of oxygen, which gives rise to two molecule of copper oxide, which is in a black oxide. So again we have one more example of that is aluminium metal. So we are getting Al2O3 from it, where 4 molecule of aluminium which reacts with 3 molecules of oxygen which gives rise to 2 AlCO3, that is 2 molecule of Al2CO3, that is aluminium oxide. So from all these reactions, what we understood? We understood that we already studied in chapter 2 where how copper reacts with the hydrochloric acid, that is a acid, right? And also which by means of we know that the metal oxides are basic in nature. Okay, basic in nature. So we know this about the natural indicators where neutral what shows that is a red litmus remains red and blue litmus remains blue. There is no change. But in acids you can see the red litmus turns into red only, means remains into red, and blue litmus turns into red for acids. Okay, but for base it gives that red litmus turns into blue and blue litmus remains blue. But okay, but aluminum oxide, we have the example. There are some metal oxides, okay, there are some metal oxides like aluminum oxide, zinc oxide shows the nature of both acid and base. It shows the nature of both acid and base, and such type of acid and base reacts with again another acid and base. Okay, reacts with another acid and base. Such type of oxides we said to be amphoteric oxides. Okay, so as you can see on the screen, the concept map for the metal oxides, which again divided into two parts: basic oxides, amphoteric oxides. So first of all, we will deal with the basic oxides. Basic oxides, which are those dissolved in water, right? Which dissolves in water. Again, it is divided into two parts: alkali and non-alkali. So alkali means which dissolves in water. Okay, you can see on the screen here. Sodium oxide and potassium oxide, when reacts with the water, they gives rise to base, that is NaOH and KOH, right? These are the alkali, which are basic oxides. Fine, but non-alkali, that is copper oxide, which does not dissolve in water. So the other one is that is amphoteric oxide. Just I told you about the oxides which shows the acid and base both the nature, and we have the example of aluminum oxide. So I just want to show you the reaction about it. Here we are getting aluminum oxide, right? When aluminum is react with the oxygen, which we are getting the aluminum oxide. Okay, again it reacts with the NaOH, that is a base, which gives rise to another salt. We are getting, right, we know acid plus salt, acid plus base, when acid and base reacts with and they form salt, right? Okay, so from all this what we can conclude that these all metals do not react with oxygen at the same time with the same rate also. So they show different reactivity towards oxygen, right? So as we know, our touch me not elements, right, sodium, lithium and potassium, right, they react so vigorously they can catch fire when you kept in the open. So that's why we have to store in a kerosene oil. But at ordinary temperature, metals such as magnesium, aluminum, zinc, lead are covered with a thin layer of oxide, and this thin layer of oxide prevent them for further oxidation. Okay, but this is not the case for the iron. Iron does not burn easily, right? Iron does not burn easily, but the iron fillings does. Okay, and the same for the copper also. Copper does not burn easily, but the copper oxide. Okay, and the same thing happens to the gold and silver also, because they are not react in high temperature. Okay, they are not react even at high temperature. That's why we are using gold and silver for the jewelry purpose. So here we are going to understand a new thing, that is about the anodizing process. This is the anodizing process where we are forming a thick oxide layer of aluminium. Okay, aluminium which develops a thin oxide layer when exposed to air, right? So this aluminum oxide coat makes the resistant to the further corrosion. Corrosion means damage to the metal, right? So this resistance can be improved further by making the oxide layer thicker. Okay, already it is covering by a thin layer, but again we are making it thicker to prevent the more corrosion. So during this anodizing, a clean aluminum article is made, the anode, okay, and is electrolyzed with a dilute sulfuric acid, and the oxygen gas evolved at the anode reacts with aluminum to make a thicker protective oxide layer, and this oxide layer can be dyed easily to give aluminum articles an attractive finish. So you can see here in the picture how this aluminum is using for anodizing purpose. From all these reactions, we are not able to conclude that only sodium and magnesium will be reactive towards the oxygen, right? But we can conclude that sodium is the most reactive towards the oxygen and magnesium is the less reactive towards the oxygen. But what about the remaining metals like lead, iron and zinc? So for that purpose we have to do more reactions and experiments. So in this video we are going to stopping here only, and in our next video we are going to understand about what happens when metals react with the water. Thanks for watching, and please subscribe and share my video to your friends and family.